In the vast expanse of our solar system, Jupiter reigns supreme, a colossal gas giant with a retinue of over 80 moons. Among these celestial attendants, Thebe, a small, enigmatic moon, orbits Jupiter with unwavering loyalty. Thebe, though dwarfed by its larger siblings, holds its own unique allure, its very existence a testament to the dynamism and complexity of planetary systems. It is a world of craters and mystery, a celestial time capsule holding secrets to the early solar system. The year was 1979, a time of great exploration and discovery in the realm of space. The Voyager 1 spacecraft, on its historic mission to the outer planets, was beaming back images of Jupiter and its surroundings. This mission, part of NASA's grand tour of the solar system, aimed to gather unprecedented data about the gas giants and their moons. Within those images, a previously unknown moon was revealed, a faint speck against the backdrop of Jupiter's swirling clouds. This discovery was a testament to the advanced technology and meticulous planning that went into the Voyager missions. This new world was initially designated S1979J2, a rather unromantic label for a celestial body. The designation followed the convention of naming newly discovered moons with a systematic code, indicating the year and sequence of discovery. However, it wasn't long before it received a more fitting name. The process of naming celestial bodies often involves a blend of scientific tradition and cultural heritage. In Greek mythology, Thebe was a nymph, a lover of Zeus, the Greek equivalent of the Roman god Jupiter. The choice of the name Thebe reflects the long-standing tradition of naming moons after mythological figures associated with their parent planets. The name is fitting given the moon's close proximity to its massive planetary companion. Thebe orbits Jupiter at a distance that allows it to be influenced by the planet's immense gravitational pull, making it an integral part of the Jovian system. And so, S1979J2 was christened Thebe, taking its place among the celestial objects named after figures from mythology. This naming not only honors the mythological heritage, but also enriches our understanding of the cultural significance embedded in our exploration of the cosmos. Thebe is the fourth moon of Jupiter in terms of its distance from the planet. It orbits Jupiter at a distance of approximately 222,000 kilometers, or 138,000 miles, completing one orbit every 16 hours. This close proximity to Jupiter means that Thebe is tidally locked to the gas giant, with one side always facing inward. However, Thebe's orbit is not perfectly circular. It is slightly elliptical, and it is also tilted relative to Jupiter's equator. This peculiar orbit is thought to be the result of gravitational interactions with Jupiter's other moons, particularly the massive moon Io. Thebe is an irregularly shaped moon, with dimensions of approximately 116 by 98 by 84 kilometers, or 72 by 61 by 52 miles. Its surface area is estimated to be between 31,000 and 59,000 square kilometers, or 12,000 and 23,000 square miles. Thebe's composition is not well known, but it is thought to be similar to that of Amalthea, another of Jupiter's inner moons. This suggests that Thebe is primarily composed of porous water ice, with unknown amounts of other materials such as rock and metal. Thebe's density is less than that of water, indicating a porous structure with significant void spaces within its interior. Section 5: Surface features, craters and mountains. Thebe's surface is heavily cratered, a testament to the moon's long history of bombardment by asteroids and comets. These impacts have left their mark over billions of years, creating a rugged and varied landscape. The craters range in size and depth, each telling a story of a collision that shaped the moon's surface. Some of these craters are quite large, with diameters of up to 40 kilometers or 25 miles. These massive craters dominate the landscape, their rims rising high above the surrounding terrain. The size and distribution of these craters provide valuable clues about the history and frequency of impacts in this region of space. Thebe also has several prominent mountains, which add to the moon's dramatic topography. These mountains are not just random formations, but are significant geological features that have been studied extensively. Some of these mountains are comparable in size to the moon itself, towering over the landscape and providing a stark contrast to the surrounding craters. Their sheer size and presence make them a focal point for scientific research and exploration. These mountains are thought to have formed as a result of impacts that lifted up large chunks of the Moon's surface. The force of these impacts was so great that it caused the surface to buckle and rise, creating these towering peaks. This process is a fascinating example of how violent cosmic events can shape planetary bodies. One of the most striking features of Thebe's surface is the difference in brightness between its leading and trailing hemispheres. This contrast is not just a visual curiosity, but also provides insights into the Moon's interaction with its environment. The leading hemisphere, which faces in the direction of Thebe's orbit, is significantly brighter than the trailing hemisphere. This brightness is due to the constant bombardment of micrometeoroids and dust particles that strike this side more frequently. This difference in brightness is thought to be caused by the impact of micrometeoroids and dust particles which strike the leading hemisphere at a higher velocity and excavate brighter material from beneath the surface. Over time, these impacts have created a noticeable contrast between the two hemispheres. The excavation of brighter material from beneath the surface reveals the dynamic processes at work on Thebe. These impacts not only shape the Moon's surface but also provide a window into its geological history, offering clues about its composition and the forces that have acted upon it over time. Section 6. The Thebe Gossamer Ring. Extending outward from Thebe is a faint, tenuous ring of dust known as the Thebe Gossamer Ring. This ring is almost invisible to the naked eye due to its delicate and sparse nature, making it a fascinating subject of study for astronomers. This ring is one of Jupiter's 4 Gossamer rings, which are so named because they are composed of extremely fine dust particles that scatter light very weakly. These particles are so small that they are almost like smoke, creating a ghostly halo around the planet. The Thebe Gossamer Ring is thought to be formed from dust particles that are ejected from Thebe's surface as a result of micrometeoroid impacts. When these tiny meteoroids collide with Thebe, they knock off small particles of dust, which then drift into space. These dust particles are then influenced by Jupiter's powerful magnetic field and radiation belts, which cause them to spiral inward toward the planet. The magnetic field acts almost like a giant hand, guiding the particles on their journey. As the dust particles spiral inward, they spread out, forming a ring that extends both inward and outward from Thebe's orbit. This dynamic process creates a beautiful and intricate structure that is constantly changing, adding to the mystery and allure of Jupiter's Gossamer rings. Section 7. The Mysteries of Thebe's Interior. Despite the wealth of information gathered by spacecraft like Voyager and Galileo, much about Thebe's interior remains a mystery. We don't know for sure what lies beneath its heavily cratered surface, though its low density hints at a porous interior, possibly riddled with caverns. The exact composition of Thebe's interior is also uncertain, as is the nature of its interaction with Jupiter's powerful magnetic field. Understanding Thebe's interior is crucial for piecing together its formation and evolution. Studying its internal structure could provide valuable insights into the conditions that prevailed in the early solar system when Jupiter and its moons were forming. Section 8. Future exploration of Thebe. Future missions to the Jupiter system could shed more light on the mysteries of Thebe. A dedicated mission to Thebe, equipped with instruments capable of probing beneath its surface, would be ideal. Such a mission could map Thebe's interior structure, determine its precise composition, and investigate its interaction with Jupiter's magnetic field. Even without a dedicated mission, future spacecraft passing through the Jovian system could conduct valuable flyby observations of Thebe. These observations could provide higher resolution images of its surface, allowing scientists to study its craters and mountains in greater detail. Section 9. Conclusion. Thebe's place in the Jovian system. Though small and seemingly insignificant compared to the gas giant it orbits, Thebe plays a vital role in the intricate dance of the Jovian system. Its peculiar orbit, its battered surface, and its tenuous ring all tell a story of gravitational interactions, impacts, and the constant interplay of forces that have shaped this distant world. Thebe stands as a reminder that even the smallest celestial bodies can hold valuable clues to the history and evolution of planetary systems. As we continue to explore our cosmic neighborhood, Thebe and its fellow Jovian moons will undoubtedly reveal more of their secrets, enriching our understanding of the universe we inhabit.